Greetings and welcome to my new calculus channel. So recently I've published a series of videos on pi and the fact that we cannot write pi is equal to pi divided by 1 because that means pi is measured by 1. And if pi were measured by 1, then it would be a rational number because guess what? Any 1 is what we use to define our rational numbers. And if a particular number cannot be defined in terms of 1 and or equal parts of 1, very important, and or equal parts of 1, then it's not a rational number, okay? And that's what it means also when you have a square diagonal on the side. You say the side cannot measure the diagonal. Why? Because the side is the unit. And although the unit fits into the diagonal once, there are no equal parts of the side that will measure that little leftover bit. Okay, so just to show you there again. So if you have this scenario, and this is the unit, then it takes, this part here is equal to this side, but there's this little part left here. Now this little part has to be described in equal parts of the side. It's impossible to do that, okay? So that's what it means to be a number. You have to be able to describe the number in terms of the unit and or equal parts of the unit. So let's go back to what he says and just read further. So then he's pretty confused. He said pi means pi over 1 means pi measured by 1. Well, if it's measured by 1, then it's a number. It's a rational number, okay? With rational being redundant. And he says we can conclude that the unit 1 measures pi exactly 3 times. Yes, that's true. And pi minus 3 equal parts of 1. Well, that to me is a mystery, and I'll explain to you why in a second. And so he tries to copy what I did, but he makes a fool of himself because that's completely wrong. Now, I just want to say one thing. In geometry, this would be true, okay, in geometry, but not in algebra, because in algebra, you need the unit and or equal parts of the unit. So let's see how this whole stuff all fits together, okay. Now, in my example, I said 5 divided by 2 means 2 measures 5 twice, right? And 1 of 2 equal parts, okay? So we've got an enumerator here. This one is the enumerator. So basically what this boils down to is that 2 times k is equal to 1, which implies that k is equal to a half. And a half is an equal part of 1. Okay, this is an equal part of 1. Why? Because a half plus a half is equal to 1, right? Right. So now idiot comes along and he says pi divided by 1 means 1 measures pi thrice, okay, 3 times, thrice, and he doesn't enumerate that. He says that the enumerator is pi minus 3, but it can't be pi minus 3 equal parts. So it's got to be, let's say, m of pi minus 3 equal parts, right? Can you see the mistake he made? Right, because this m has to be an enumerator, right? So this means that m times pi minus 3 must equal to 1, right? Which implies that m is equal to 1 over pi minus 3. But this is a contradiction here, because m must be an integer, okay? And it's not. Try it. Look, just take your calculator, Let's do this. Let's say pi minus 3. Okay. Do you see? 7.06. Doesn't matter. It's got a fractional part. Therefore, it's not an integer. So he hasn't actually shown that pi can be measured by 1. And his understanding is all wrong. Basically, he's failed to make all the connections. And this is typical amongst mainstream educators, such as math professors and teachers. They suffer from a very popular syndrome called Dunning-Kruger. What it means is they think that they know better than everybody else, and they're absolutely convinced that what they think is correct, but it's not. And so it leads me to one conclusion. They're all cranks because, as far as I'm concerned, a crank is a person who cannot be convinced even in the face of overwhelming evidence. So, you give them this evidence, you show them their mistakes, okay? So you show them the mistakes, but this fool will still come back and say that the way I showed this also shows that pi divided by 1 is equal to pi, which is false, okay? False. Because if pi divided by 1 is equal to pi, then pi is a rational number, okay? Because that's what this process means. It means take the divisor, which is 2, and measure the dividend, okay? Measure the dividend in parts of 2 and equal parts of 2. So what we have here is 2 plus 2, 2 plus 2, and the enumerator of one equal part, the enumerator of an equal part, which is 1, plus 1 of 2 equal parts, right? You can't do, with his drivel here, you can't do that. I mean, what are you going to say? You're going to say 1 plus 1 plus 1, and then what's the enumerator going to be for equal parts of pi minus 3? There isn't an enumerator. There isn't such an m, okay? So that's why you cannot measure pi using the unit, because pi is not a rational number. Anything that the unit measures is a rational number. Right, so that's pretty much it. My name's John Gabriel, and this is New Calculus Channel. If you're not a rare subscriber, become one, because look, this is the kind of thing that you miss out on. See here? A members-only video from geometric to algebraic arithmetic, putting it all together, and I show you in this video how it all fits together seamlessly. It's beautiful. It's amazing. Become a member for $4.99 a month, and follow me on academia.edu. By the way, to be able to see any of the academia articles, you first need to log into academia. Otherwise, you'll get the message you're in the wrong aisle. And you can also become a subscriber to this channel, right? To my YouTube channel, which I'd appreciate if you do. And finally, click like so that the algorithm can take this fantastic knowledge and spread it to more people, instead of just limiting it to a few people who are very bright and to the majority who are morons. I'm John Gabriel, and this is New Calculus Channel. Till next time, goodbye.